So moving on to how to find the length of a straight line between 2 points. Again, so let's say you have a line like here, but this point being XA, YA, and then this point here being XB and YB, and then you just want to find the length of this point. So you just do that using Pythagoras theorem. You'd have so if you just draw a triangle like this, then you'd have this length here. That's just the same as XB minus XA, and then you have this length here, and that's just the same as YB minus A. So you just use Pythagoras theorem, and so you just use square root of this length XB minus XA squared plus this length here, which is YB minus YA squared. So we can try this out with this example question here. So again, feel free to pause the video and try it out for yourself. So you want to find the exact length of the segment of the line with equation y equals 5x minus 2 between x equals 3 and x equals 4. So to do that, we only have the x coordinates. We want to try find the y coordinates. So to do that, we just plug in x equals 3 into the equation. So you'd get, for x equals 3, we'd get y equals 5 times 3 minus 2, which is just 15 minus 2, and that's just 13. And then for the next one, we have 5 times 4 minus 2, so that's just 20 minus 2, which is just 18. Then if we write out the coordinates that we have XA, YA, that's just equal to 3 and 13. And then we have XB and YB, and that's just equal to 4 and 18. So we could just plug that into the formula for the length. So then we get the length, that's just equal to XB minus XA, so 4 minus 3 squared, plus YB minus YA squared, so that's just 18 minus 3 squared, and that's just equal to 1 squared plus 18 minus, so that was 13, so that's just plus 5 squared. So you get the square root of 25 plus 1, which is just the square root of 26, and that is the length of the segment of the line between these 2 points. So the last bit you need to know for straight lines is how to find the intersection points between 2 straight lines. So what you do is you just have 2 equations, and all you do is you want to find the values of x and y that intersect, so that satisfies both equations. So all you do is you just do like normal simultaneous equations. So if you've forgotten how to do simultaneous equations, make sure you review that lesson again, and then you can come back and try and solve this question. So we're going to try and find the intersection points between y equals 3x over 2 minus 5 and 3x minus 4y equals 8. So to do this, we could just plug in, we could use the substitution method here, and we could just plug in y equals 3x over 2 minus 5 into this equation. So we get 3x minus 4 all times 3x over 2 minus 5, and that's all equal to 8. So then if we multiply out this bracket, we'll get 3x minus 4 times 3x over 2, so that's 12x over 2, which is just minus 6x. And then minus 4 times minus 5, that's just plus 20, and that should be equal to 8. So then if we collect the like terms, we get minus 3x plus 20 is equal to 8. Then if we rearrange, we can subtract 8 by both sides, we get 12. And if we add 3x to both sides, we get 12 equals to 3x, then x equals to 4. So now we found our x value, our x coordinate. We can just sub that back into one of these equations to find the y coordinate. So then we get y, if we sub it into this equation here, we can get y equals 3 times 4 over 2 minus 5, which is just 12 over 2, which is just 6 minus 5, which is equal to 1. So then the intersection points is just 4 and 1. So now if we try an exam style question on straight lines, see if you've understood what we've covered this lesson. So again, feel free to pause the video and try it out for yourself. So we have a straight line L1 passes through the points -1, 3, and 11, 12. We want to find an equation for L1 in the form ax plus by plus c equals 0. And then we want to, so let's do that question first. So we can use the form we had y minus y1 equals m, and then x minus x1. So if we use that form to try first, so the first thing we want to do is we want to try and find m. So m is just y, the change in y over the change in x. So we'd have to do 3 minus 12. So we have 3 is y1 and 12 is y2 over -1 minus 11, with -1 is x1 and 11 is x2. And that's just equal to 3 minus 12, which is just -9. Then we have -1 minus 11, that's just -12. And if we cancel, if we simplify this, we will just get 3 over 4. So that's just that's just m. Now we can just plug in the values using x1, y1 is equal to -1 and 3. Then we would have y minus 3 is equal to 3 over 4 x minus 1, so x plus 1. Then if we expand everything, we'd get y minus 3 is equal to 3/4 of x plus 3/4. Now if we carry on over here, we can just because we want it in the form ax plus by plus c, if we just multiply everything by 4, then you would get 4y minus 12 is equal to 3x plus 3. Then we want to put everything on one side, so we have 0 on the other side. So if we bring in 3x onto the left side, so we subtract 3x on both sides, we'd get 4y minus 3x, and then if we subtract 3 from both sides, get -15, and that's equal to 0. So that's how you would solve part A. Now if we move on to part B, we want to find the coordinates at the point of intersection of L1 and L2, with L2 being 3y plus 4x minus 30 is equal to 0. So if we just write that out. So to do this, we can make them into two simultaneous equations again. So if we just rewrite that, then we'd have 4y minus 3x equals 15. Then we'd have 3y plus 4x is equal to 30. So if we want to rewrite this, so we label this 1 and 2, then the first thing we want to do is we want to try and eliminate one of the x's, so we can all y's. So the first thing you could do is you could times, if you want to make all the y's equal to 12y, we could do 4 times 3, and then we can multiply this one by 4. Then you would get 12y minus 9x is equal to 45. Then you would also have 12y plus 16x is equal to 120. Then if we were to subtract, so if we label this 3 and 4, and then if we were to subtract 4 by 3, if we did 4 minus 3, and that would get rid of y, we also get 16x minus 9, so that's just 25x. Then if we did 120 minus 45, we get that is equal to 75. So that means x is just equal to 3. So now we found the x coordinate, so then we could just plug that back in to any of these equations to find y. So we just plug it into the first one, and we get 4y minus 3 times 3 is equal to 15. So then we have 4y is equal to 15 plus 9, which is just 24. And then y would just be equal to 6. So we have this coordinates at the point of intersection is just 3 and 6. So hopefully that was useful, and you know now know how to understand and know the three forms of the straight line, and you can find the gradient of perpendicular and parallel lines, and you're also able to find midpoints, distances, and intersection points. So make sure you do some more practice questions just to make sure you fully understand all the topics we've covered. But otherwise, thanks a lot